Greetings! This is Unit 5, Module 4, Session 2. The name of this home connection is Clock Angles and Shape Sketches. It's a two-pager. Name and number, please. Follow the directions below to construct an angle on each clock face. Use a ruler or a note card to keep your lines straight. Okay. I do have a little protractor here that I'm going to be using as my straight edge. It's got a broken bit on it, but the straight part's still okay. For each one, give the measure of the angle and explain how you know it's that many degrees. Hint, a circle measures 360 degrees. So an hour on a clock, if you follow the big hand around, that's 360 degrees. Draw a line from the point above the 12 to the center of the clock. So there's the 12 to the center of the clock. Boom. Okay, that's just what I did. And a line from the center to the point beside the 3. Now in this case, you could use a protractor to find your answer, but this is a quarter of a turn. From here, I maybe add a little red on here. From here to here. Okay? The whole circle is 360 degrees, but this is just a quarter of a circle. You might even think of it this way. It's like 1/4 would be the same as what out of 360? Okay, so it's like we're trying to figure out how much of the 360 degrees is 1/4 of a circle. Well, what times 4 is 360? Oh, that might be hard math, but what if I got rid of the 0? Would that be a little bit better? What times 4 is 36? Well, I know that 9 times 4 is 36. Put your 0 back on, you get 90 degrees. We also know that this just appears to be a square angle. Okay, squares are 90 degrees. Okay, the angle is 90 degrees. Here's how I know. Well, I put some reasoning here, but you could also write a quarter of a circle is 90 degrees, that sort of thing. Okay. B says draw a line from the point above the 12 to the center of the clock. So I'm going to do that first. From the 12 to the center. Boop. Okay. And a line from the center to the 6. Ooh, interesting. I think I know what's going on here. Well, how much of a circle is that from here to here? That looks like half a circle. It's also a straight edge. We know that a straight edge is 180 degrees. We know that half of a circle, we could say half, if we wanted to maybe set it up like the formula up here, half would be the same as what out of 360? 180, right? You could get rid of the zeros. 18 is half of 36. But half a circle is 180 degrees. That would be like if you were standing in a room, let's say this is the top of your head, and maybe this is your nose, okay? And you're looking this way. Okay, if I turn all the way around, so I'm facing the other direction, I've done a 180-degree turn. Okay, that's kind of my visual for you for the day. Half a turn, 180 degrees. Next one says draw a line from the 12 to the center. Okay, so just like before. And then from the center to a point beside the 1. Uh-oh. This is going to be a little bit more challenging, isn't it? Because it's such a small amount. It's less than 90, right? Because 90 is the quarter of a circle. But maybe we should start with that. I'm going to do some blue drawings in here, okay? If we went to the 3, that would be 90 degrees. Okay? But if I split this whole quarter of the circle into 3 pieces, so I have 1, 2, 3 angles, we know that these 3 angles equal 90 degrees. Okay? How do I split 90 into 3 different equal pieces? Well, how do you split 9 into 3 equal pieces? Well, if you split 9 into 3s, those are equal. Put your zeros back on. 30, 60, 90. So So each one of these wedges, each one of these angles represents 30 degrees. So from 12 to 1, that is 30 degrees. Each hour on the clock represents 30 degrees. If you were to add all 12 of them up, you would get 360 degrees. So our answer is 30 degrees. And I'm sorry that that camera's acting funky. Let's see if I can trick it. Maybe I'll bounce a little bit. Sometimes that helps. Gets a little confused. Oh my goodness, this is going to be interesting. Oh, well, let's see. Ooh. Focus, 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 focus. There's focused a little bit. Trying to trick it into focusing on the paper. Still seems a little blurry. Okay, hopefully you can read it on your paper while I do this. Draw a line from the 12 to the center. Okay. Draw a line from the center to the 4. Uh-oh, SpaghettiOs. Actually, not too bad here. So this angle that we're trying to measure here, it's more than 90, less than 180. I kind of wonder if we want to use both of the ideas that we talked about already. Okay? Man, I wish that would be just a little less blurry. What if I turn the lights off? Does that help? Got a button on here that's supposed to autofocus, but I am struggling. There we go. I'm going to do a little dotted line here. We know that a quarter of a circle, this is something we need to memorize. It's just worth knowing. This is 90 degrees. But we're going to the 4, which is a little bit more. In our last problem, what did we say? Each hour, so like 12 to 1, or 1 to 2, or 2 to 3, doesn't really matter. But if I have a small angle using 2 hours on the clock, that's 30 degrees. So if I look at this, I already have 90. What do we say the small angle was? 30. I think we should do a little addition problem where we do 90 plus 30. If you do your standard algorithm, the zeros add up, the 9 adds to 12, we have a 120 degree angle. And when you write your explanation, you can write, oh, I know that a quarter of a circle is 90, and that if you add an hour on a clock, you add 30 degrees. Bada boom. Write instructions to a friend explaining how to sketch a 60 degree angle on a clock. Well, goodness gracious, we should probably start with a 60 degree angle. And normally I'm really prepared and have awesome like round things that I can trace, but all of them are either really big or really small. And I don't feel like going around the room to hunt something. So, draw a clock. Label 12. Label 6. Okay. Put your center in. Remember, we're trying to do a 60 degree angle. So we always have to start with our 12 o'clock. That's what we did on the last page, right? And we're going to do 60 degrees, okay? So what if I was talking to the friend, I would say that 1 hour is 30 degrees. So 2 hours is how many? 1 hour is 30. 2 hours would be twice as much. 30 plus 30 is 60 degrees. So if we're trying to sketch a 60 degree angle, we need to move 2 hours on the clock, right? So if we're starting at 12, move 2 hours, what do you get? 1, 2, and then we draw our straight line to the center to get our 60 degree angle, okay? That's how I would explain it to a friend, because we know that every hour that you move on the clock is 30 degrees, so you moved 30, 60, and then drew your line. That's how I would explain to make a 60 degree angle on a clock. Danny is learning to make a full turn of 360 degrees on his skateboard. So far, he can make a turn of 270 degrees. So he's not quite to a full turn, but when you say how many more degrees does he need to get to make a full turn? It says use numbers, labeled sketches to solve your problem. So we could even use a number line. We could start at 0. He gets to 270. The question would be, how far, maybe I'll put it in red, does he need to go to get to 360? So we're measuring this bit right here. Well, we could count up 270 to 300, right? We could get to 300 by going up 30 plus 30, and then, so that's 300, and then go up plus another 60 to get to 360. 60 plus 30 is 90. So we could use a number line and go that way. I could also take 360 and subtract 270. 0 minus 0 is 0. Oh no, there's more on the floor, so I got to go next door. So I'm going to borrow a 1 from this 3, making it a 2. 16 minus 7, what is that? 9. 2 minus 2 is 0. So, whoa, what do you know? 30 plus 60 is 90. 360 minus 270 is also 90. A couple ways you can do it. So he needs to get to 360 degrees. If you're going to use like maybe the idea of a clock or just a circle in general, if we represent 0 here, we know that a straight line is 180. We know that if we count by quarters, right, then we go 90 degrees here. So this line here is 90. And then we add another 90 as we go around the circle, which gets us to 180. We add another 90 degrees to get us here, and that's 270, right? So he's just missing this last 90 degrees to get a full spin. So he went all the way around 90, 180, 270, and he stopped right here. Boop. So the idea would be how much is left. That one's not too bad to figure out if you have it pictured, correct? Because a quarter of a turn is 90 degrees. Sketch the following if they are possible. If they are not possible, explain why they can't be sketched. A triangle with parallel sides. Oh, goodness, let's try it. So here's my 2 parallel sides. They'll never touch. Oh, gosh, I can't make that a triangle because if I have 3 lines, at least 2 of them will never touch. So this shape will never close. So you could write that in there. That shape will never close. A trapezoid with 2 lines of symmetry. Well, a trapezoid has 2 parallel sides, okay, and then 2 sides that are not parallel. So maybe that goes out, but this one goes out a lot more. So we have, clearly, these 2 lines are not parallel. Does it have a line of symmetry? This has no lines of symmetry. Ooh. But what if I use my standard trapezoid? I'm going to reach into my bag of tricks here and grab the good old-fashioned trapezoid. Well, this has 1 line of symmetry down the middle. Oh gosh, I'm not sure that's possible, but I'm going to let you think of it. 2 lines of symmetry. See if we can figure out a way to fold this or another type of trapezoid in half twice. A pentagon with 2 right angles. Ooh, okay. 2 right angles, so we'll go maybe... like this. There's my first right angle. Here's my, oops, it's easier to do it that way. How do I do that? Like this. So there's a right angle. There's a right angle. So there's 2 right angles. I have 3 sides. I need to have a total of 5. So I just need 2 random lines. And then we should be good, right? Count my sides. 1, 2, 3, 4, 5 sides. That's a pentagon. 2 right angles. Totally possible. Nailed it. I bet your teacher's looking forward to seeing the different shapes that you create. Remember, you do not have to draw the way that I draw. I just knew I needed 2 right angles, but I mean, your shape could be turned this way. I mean, it could be 2 right angles like this. Maybe both of your right angles are on the top of your shape. Maybe they're opposites. Maybe this opposite angle here, you put in a right angle, and this one is not right. It's up to you. But if you have questions, make sure you ask a teacher. We love to help out. Maybe you have a friend or an adult that's also enjoys math as much as we do. Ask them for help. We are here for you, okay? Check you later.